All right, today we're going to do lesson 2.4, solving multi-step equations. All right, we have talked about this already today, but let's just mention it again. We solve inequalities the same way that we solve equations. All right, there's two extra things that we're doing though when we're talking about inequalities. Number one, we're asking ourselves a question before we box in our answer. What is that question? Anybody remember?
Did we multiply or divide by negative?
Okay, the question is, do we need to flip the sign? Okay, then we say, did we multiply or divide by a negative number to finish the problem? All right, everybody give me some nods. Do you remember that question? All right, the second thing that's a little bit different is we are graphing our solutions, and we graph our solutions on a what?
Number line.
A number line. All right, very good. Now, in order to solve multi-step inequalities, we're going to use the exact same acronym that we used with multi-step equations. So let's go over once again, don't call me after midnight. What does the D stand for? The distributive property, all right? Everybody write it down. The distributive property. That's the first thing that we are going to check for. We're going to see if we need to do the distributive property, all right? Call. What's the C in call stand for?
Combine like terms.
Combine like terms. Now, we're looking for like terms that are what? Does anybody remember? On the same side, this time, of the inequality. So we're looking for like terms that are on the same side of the inequality. All right, Myri, me. Don't call me. What's the M stand for? Not yet. What's the first M stand for? Trevin, do you remember? Dalton, do you remember? Nobody remembers but one person who's answered every question for me already. I don't want to hear from him. Okay, Trevin. Move the variable. Very good. Very good. We're going to move the variable. What side of the problem are we attempting to move the variable to?
Left.
The left. Okay, if at all possible, we want to move it to the left. All right, Myri, back to you. The A. Do you know what the A stands for? Don't call me after. Deja, do you remember? Add or subtract. Remember, we're not looking to add and subtract. We're looking for a number that can be moved with either addition or subtraction. All right? Myri, the last M. Don't call me after midnight. Multiply or divide. Very, very good. Okay? Now, my guess is this is why, if you're looking, as you were looking at your test, okay, my guess is maybe you messed up on these multi-step equations, all right? So hopefully you understand now how important learning this acronym is, okay? It will help you. Some people didn't move variables like they were supposed to. They wrote no solution, okay? They didn't combine like terms on the same side of the equal sign first. So understand this acronym is very, very important and very, very useful. All right, so let's look at example number 1. They want us to solve the inequality and graph the solution. So looking at letter A, I want you to think through those steps that we just talked about. Which step are we going to start with? All right, go ahead, Trevin. What are we going to do first on letter A? Very good. There's no distributive property, there's no combining of like terms, and there's no variable to move. So we're going to add or subtract, and we're going to subtract 8 from both sides. So we bring down the negative 9c, and it's greater than or equal to?
Negative 9 by both sides.
Hold on. I'm not there yet. What is negative 28 minus 8?
Negative 36.
Negative 36. All right. Alonzo, how do we solve for C?
You have to divide by negative 9.
Good. We have to finish. We have to divide both sides by negative 9. And so C is greater than or equal to 4. Now, before I box in my answer, what's the question I have to ask? Do I need to flip the sign?
Yes, it's divided by negative 9.
Very good, because the last thing I did to finish this problem was divide by a negative number. So absolutely, I'm going to flip the sign. So C is less than or equal to 4 is my final answer. All right, good job. Now let's graph it. What goes in the center of our number line? 4. We're going to do 1 to the right, which is 5. 1 to the left, which is 3. All right, Anthony, my circle, open or closed? Why closed? Very good. It's or equal to, so I know my circle is closed on 4. And Anthony, is my arrow going to the right or the left? Good. My solutions are supposed to be less than or equal to 4, so less than is to the left. Okay, very good. Very good. All right, let's look at letter B. Dalton, what would you do first on letter B? Now be careful, because remember, we're trying to get in by itself. So we're trying to move things away from in. So try again, Dalton, and tell me what you would do. Good. We want to move things away from in, so we're going to subtract 11 from both sides. So n divided by 2 is greater than, class, what's 12 minus 11? 1. Very good. All right, Joshua Eisenberg, tell me how to solve for n. No? Now read, okay, Joshua, read the problem to me. Not over. N
divided by 2.
Okay, n divided by 2. So what's the inverse of dividing?
Multiply.
So we're going to multiply both sides by 2. So when we do that, these 2 cancel, because 2 over 2 is 1. And n is greater than, class, what's 1 times 2?
2.
2. Now, what's the question we ask ourselves?
Do we flip?
Do we flip the sign? Do we flip the sign? No. The last thing we did was multiply by a positive number. So this is our answer. All right, in the center, we got a 2. To the right, a 3. To the left, a 1. Yasmin, will my circle be open or closed?
Open.
On what number?
2.
Open on 2. And why open?
Because only greater than.
It's just greater than. All right, and then my arrow's going in what direction?
Right.
To the right. Awesome job. All right, any questions? Timothy.
When do you flip the greater than or less than sign?
When the last thing you do to solve the problem is multiply or divide both sides by a negative number. So if you look back at letter A, the last thing we did to finish this problem was divide both sides by a negative. So we had to flip it. Okay, but here the last thing we did is multiply both sides by a positive, so we didn't have to. All right, now I want you to take a minute with your table and I want you to work letter C. All right, guys, let's everybody back to the front of the room. Let's talk about what you did. Okay, if you're still working, that's fine, but work quietly. All right, Noah, what did you guys do first on letter C?
We added 12 on both sides.
All right, but does that follow our acronym, Don't Call Me After Midnight?
No.
What did we forget? Deja.
What I did was I added 3x to 5x.
Okay, did you add it though?
I subtracted it.
Okay, so if I'm doing Don't Call Me, the first M stands for move the variable. Okay, and we have a variable on both sides. Now, let me show you what I saw on some people's tests. Again, not necessarily this class, but on some tests, maybe it was this class. But I saw that when we subtracted a variable term, I got this right here. Can you subtract a variable term from an unlike term? No, I can't subtract negative 12 and negative 3x. They're not like terms. So be really careful. When you're moving that variable term, make sure you're putting it underneath its like term. Okay, so we know it cancels there. 5x minus 3x is 2x. Minus 12 is less than or equal to negative 4. All right, Alonzo, what did you guys do next?
After that, we added 12 to both sides.
All right, good. Now we're at the add or subtract, so we're going to add 12 to both sides. So 2x is less than or equal to 8. All right, very good. Sue, what did you guys do next?
I divided 2.
Okay, divide both sides by 2. So x is less than or equal to 4. Now the question, do I need to flip the sign? No, you do not. The last thing you did was divide by a positive number, so you can box in x is less than or equal to 4. Now, hopefully you can keep working down your paper. I'm running out of room. All right, but we've got 3, 4, and 5 on our number line. Trevin, is my circle going to be open or closed?
Open. But I have a question.
Okay, hold on. Answer my question first, and then I'll take yours. Is my circle going to be open or closed?
Open.
Look at your answer.
I mean closed.
Closed. Okay, good. Why is it closed, Trevin?
Because less than
or equal to. All right, and if it's less than or equal to 4, what direction is my arrow going? Trevin?
to the left.
To the left. All right, very, very good. All right, let's look at letter D. What should we do first? Distribute. Very good. What are we distributing? We're going to distribute the 3. So what do we get when we distribute the 3? 6a minus 3 is greater than or equal to 10a minus 11. Very good. All right, Shonda, what would our next step be? Good. We're going to subtract 10a from both sides. Okay, when we do that, we get negative 4a minus 3 is greater than or equal to negative 11. All right, Yasmin, what do we do next?
Divide by negative. Oh wait, no, plus.
We're going to add 3 to both sides. Again, following our acronym, we're going to add 3 to both sides. So we have negative 4a is greater than or equal to negative 8. All right, Deja, how are we going to finish this? Divide. My space is running out. All right, so a is greater than or equal to what, Deja?
-2.
Is it negative?
No.
No, a negative divided by a negative is a positive, okay? But do we need to flip the sign? Yes. So our answer is actually A is less than or equal to 2. Okay, again, keep working down your paper. Hopefully 8 lines was plenty. I am just running out of space. All right, our graph. Let's talk about our graph. We got 2 in the middle, 3 to the right, 1 to the left. Will my circle, Alonzo, be open or closed?
Closed.
It is closed on what number?
2.
2. And my arrow is to the what?
It's going to the left.
Going to the left. Awesome. All right. Let's look at letter E. All right. Again, what is the first thing that we're going to have to do to letter E? Distribute. So we distribute the 2. And what do we get when we distribute the 2?
2k minus 10 is less than 2k plus 5.
Awesome. 2k minus 10 is less than 2k plus 5. So Michael, how are we going to solve this one? What are we going to do first?
Subtract 2k.
Good. We got to move that variable to the left. So we're going to subtract 2k. Now, again, let's talk about what I saw on the test. First of all, for some people, I saw this right here. Now, that doesn't make sense to me only because what is 2 minus 2? 0. Okay? That answer didn't make sense. Now, when I saw this answer, I understood a little bit better. However, what are they asking us to do? So what are they asking us to do when we have a 0 and a k side by side with nothing between them? And what is 0 times anything? 0. So this is not necessary. It just crosses out. Because then we have negative 10 is less than 5. Now, our variable is gone. So the question is, do we have a true statement? Is negative 10, read it again. Is negative 10 less than 5? Yes. So, with equations, it was infinitely many solutions. With inequalities, it's all real numbers. It's all real numbers. All right? But again, got to show me. Got to show me this right here. This is another thing that happened on the test. People skipped this step right here. They drew the line and then they just wrote all real numbers. Well, how? How do you know that? I got to see the negative 10 is less than 5. All right, look at letter F. What are we going to do first on letter F? Distribute. Okay? So when we distribute, what do we get?
Negative 12n plus 4 is greater than negative 12n plus 5.2.
Very good. We distribute and we get negative 4 times 3n, which is negative 12n. Negative 4 times negative 1 is positive 4. And then we bring down what we have not used. All right, so what would our next step be? All right, Trevin.
To subtract. To combine or add 12 in.
Good. We're going to move the variable, so we're going to add 12n to both sides. Now again, what is negative 12n minus 12n? 0. So these both cancel, and we're left with 4 is greater than 5.2. Now, is that a true statement? No. So what do you think our final answer is? How about no solution? How about no solution? All right, that one looks just like equations. When the variable is gone and the statement is false, it's no solution. Are there any questions? Yes.
Anytime the variable is crossed out and the statement is true, it equals all the
Yes. If the variable's gone and the statement is true, it's all real numbers. If the variable is gone and the statement is false, it's no solution. Okay? Lastly, let's look at example number 2. Write an inequality and solve. So let's pick this problem apart. A lot of you did really good on the word problem. Some of you still struggled. So let's look at this. An amusement park charges $5 for admission and $1.25 for each ride. You go to the park with $25. What is the maximum number of rides you can go on? Okay, now first of all, $5. How many times are we paying that $5? Once. So let's just write it down one time. It's then going to cost us $1.25 for each ride. Now, what operation do we think of when we see the word each? Multiplication. So it's $1.25 x. Because it's $1.25 per ride. Now, are we adding these two things together or are we subtracting them? Because I got to pay $5 to get in the park and then I got to pay $1.25 per ride. And this says I go with $25. So do I have exactly 25? Do I have more than 25? Or do I have less than 25? Okay. I have $25 exactly. So I know it's my or equal to, but it's an inequality. So is it less than $25 I have to spend? 25 or less or 25 or more?
25 or less.
25 or less. So it's less than or equal to 25. And now we're going to solve the inequality. Sorry, I didn't like that it was all the way over there. All right, what am I going to do first?
minus 1.25.
Nope. It's already a positive 5. So I'm going to subtract 5 from both sides. Okay, very good. I've got $1.25 times x is less than or equal to 20. Now how am I going to finish this? Divide both sides by 1.25 or $1.25. So x is less than or equal to 16. Now, do I need to flip the sign? No, I do not. And this is a word problem, which means I have to label it. So x is less than or equal to 16 rides. That means I can ride 16 or less rides at the fair. All right, and that is lesson 2.4.